Hello everybody, this is Rashi Berry from Columbia University.
And this is Warner Berry from NYU.
Alright, so today, Shubhana, I'm thinking of a problem. For example, displacement problem. For example, you start moving, I don't know, can you remember those numbers? 10 meter to the north,
Okay.
90 degree with respect to the x-axis,
Okay.
and then you turn around 30 meter southeast.
We go up 10 meters. And then we go southeast. So I'm going to draw a little, I think Cardinal Rose it's called. So southeast is
Cardinal what? Cardinal what?
Rose.
Oh, how do you spell rose?
Rose, like the flower.
Oh, really?
Usually because it looks kind of like a flower.
Never heard of this term. Okay, my knowledge is, I'm going to store this to my knowledge.
Okay, so 30 degrees southeast, I think means something like this.
Yes, it's going to pass that.
I don't know why it keeps forcing it to be a line.
I think it's going to pass the x-axis.
Okay, so wait, okay. This is 30 degrees, right?
Yes, and that is...
So this is 10, this is 20.
Yeah.
So this is 30. So this is just a 10, 20, 30 right triangle.
Okay, sure.
Okay, which means that the total displacement in blue is just going to be equal to the square root of 20 squared times 10 squared, which is, of course, equal to the square root of 300, which is equal to 10 root 3.
All right, now can you do parallelogram way?
I don't know why you would do that. It's so inefficient, but you take this. But how are you even supposed to find it with a parallelogram?
Okay, we'll see. All right, so if that is 30 degree, that must be 60 degree.
Yes.
And that must be 120.
This is 120, yes.
So you're going to use parallelogram formula, r square is equal to a square plus b square plus 2.
This seems like the least efficient way to do it.
No,
especially because that won't work since this is not the hypotenuse.
So let's see law of sine or law of cosine.
Okay, I guess you can use the law of sines. A over sine cos. I think.
I think is small lowercase a over angle is always uppercase.
Yeah, obviously. I'm just doing it quickly. So the length of A, I guess, is 10. The opposite angle is 30. So sine of 30 is 0.5. That's equal to B. B is 20. Sine of 90 is equal to 1. So C over sine C. So that's sine 60. So that means that 20 has to be equal to C over sine 60, which means C is equal to 20 sine 60, which is equal to 20 times the square root of 3 over 2, which is 10 root 3.
Yeah. All right. So angle.
What?
The angle for the resultant.
The angle for the resultant is 0.
Oh, which one? Oh, yeah, that's right. Angle for the resultant is 0. Very nice. What about the parallelogram way? Can you? Oh, yeah, that's also.
It would give the same thing, of course.
Angle of that, yeah. So when I choose the problem, I did not choose it carefully. Instead of 30 meter, if I do 60 meter, how are you going to do it?
Oh, making this 60?
Yes. It's going to pass x-axis.
Have to erase the whole thing. Okay, so then this is no longer going to be 120. Let's get rid of this line. Now we have to draw this again. and even and again, which makes the total resultant now this. So, how do we find that? Well, this time we can do something very simple as well. As you can see, this point right here is 0, 10, since you went 10 units up. Now, this point right here, which is 20 away, 30 degrees southeast, so 20 meters away, 30 degrees southeast, brings you to 10 root 3, 0, which means that this translation is minus 10 in the y.
How do you know it is 10 root 3?
That's what we calculated the first time.
Oh, okay.
So now we just add this on top. We go another 20 meters southeast. That gives us 20 root 3 minus 10. We go another 20 meters southeast. That gives us 30 root 3 minus 20. And now we calculate the final distance. Since we're calculating from the origin, we just get the square root of 30 root 3 squared plus 20 squared, which is 2700 plus 400, which is the square root of 3100, or 10 root 31. And if you want an estimate, I think that's about 55.
I don't have a calculator, otherwise I could verify that answer. Do you verify this answer? R squared is equal to
10 root 31. Yeah, 55.67.
Oh, that's close enough.
I mean, it's about halfway between root 25 and root 36.